Good morning, students. This is our fourth lecture on sampling theory. In last lecture we discussed t-test for small samples. Now in this lecture we will discuss for small samples test of difference between means. So there are two types. First one independent samples and second one dependent samples. So here we are testing null hypothesis to be mu1 equal to mu2 and alternate hypothesis as mu1 not equal to mu2. And here test statistics is t equal to x1 bar minus x2 bar divided by sigma into under root of 1 by n1 plus 1 by n2. Now here we can find out value of sigma using these two formulas. So first formula, sigma equal to under root of n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2, where s1 and s2 are the standard deviations of the sample, or sigma equal to under root of summation of x1 minus x1 bar square plus summation of x2 minus x2 bar square divided by n1 plus n2 minus 2. Here mu equal to n1 plus n2 minus 2 is the degree of freedom. See this example. The means of two random samples of size 9 and 7 are 196 and 199 respectively. The sums of squares of the deviations from mean are 27 and 19 respectively. Can the samples be considered to have been drawn from the same population? Now here two samples are given and their sizes are 9 and 7. So this is an example of small samples. So what are the given things? N1 is 9 and x1 bar is 196. N2 is 7, x2 bar is 199. Now one more thing is given here. Sums of squares of the deviations from the mean. Now observe this summation. You can read this as sum of squares of samples from mean. So sum of squares from mean are 27 and 19. That is, summation of x1 minus x1 bar square is 27 and summation of x2 minus x2 bar square is 19. So these are the given things. So we have to test h0 as mu1 equal to mu2, h1 as mu1 not equal to mu2. So the formula is t equal to x1 bar minus x2 bar divided by sigma into under root of 1 by n1 plus 1 by n2. Now here we know x1 bar, x2 bar, n1, n2. Unknown thing is sigma. So we know the formula sigma equal to under root of summation of x1 minus x1 bar square plus summation of x2 minus x2 bar square divided by n1 plus n2 minus 2. And its value is given, which is 27. Its value is 19 divided by n1 is 9, n2 is 7 minus 2. So this is under root of 46 by 14, which is under root of 3.28, which is 1.81. So you know sigma. Therefore t equal to x1 bar 196 minus x2 bar 199 divided by sigma is 1.81 to under root of 1 by 9 plus 1 by 7, which is minus 3.33. So absolute value of t calculated is 3.33. Now here level of significance is not mentioned, so consider level of significance at 5% with degrees of freedom n1 plus n2 minus 2, which is 14. So from table you will get this value. So t tabulated is 2.14, that is at 5% level of significance with 14 degrees of freedom, value of t is 2.14. So here calculated value, this calculated value is greater than tabular value. Therefore we reject h0, and rejecting h0 means the samples cannot be considered to have been drawn from the same population. Second example, two independent samples of sizes 8 and 7 contain the following values. So data for sample 1 and data for sample 2 are given. So is the difference between sample means significant? We have to check it. So first sample values of x1 are given. Second sample values of x2 are given. So for using this test we require values of x1 bar, x2 bar and sigma. So first we will find out x1 bar, x2 bar and sigma. So for sample 1 x1 is given. So consider deviation from mean. So here values are small, so we can find out mean directly. So x1 bar is summation of all the values, which is 136 divided by numbers 8, so 17. So we will consider di equal to x1 minus x1 bar, that is x1 minus 17. So 19 minus 17 2, 17 minus 17 0, 15 minus 17 minus 2, and so on, 14 minus 17 minus 3. And its square, 2 square 4, 0 square 0, minus 2 square 4, and so on, minus 3 square 9. So summation of di square is 36. Now see here, for sample 2, values we will consider x2, and these are the values. So mean of sample 2 is summation of all x2s are 112 divided by 7, which is 16. So we will consider di to be x2 minus x2 bar, that is x2 minus 16. So 15 minus 16 minus 1, 14 minus 16 minus 2, and so on, 16 minus 16 0, and its square. So summation of di square equal to 20 for sample 2. Now we have to test here. H0 is defined by mu1 equal to mu2, and H1 is defined by mu1 is not equal to mu2. So test statistics is t equal to x1 bar minus x2 bar divided by sigma into under root of 1 by n1 plus 1 by n2. Now we require value of sigma. So sigma equal to under root of summation of x1 minus x1 bar square plus summation of x2 minus x2 bar square divided by n1 plus n2 minus 2. And see here, summation of x1 minus x1 bar square means this thing. Di means x1 minus x1 bar, and square means x1 minus x1 bar square, and its value is 36. So this is 36 plus this value is 20. So 36 plus 20 divided by 8 plus 7 minus 2, which is 2.07. So calculated value of t equal to x1 bar 17 minus x2 bar 16 divided by sigma is 2.07 into root of 1 by 8 plus 1 by 7, which is 0.5, and its value is 0.96. So level of significance is not mentioned. So at 5% level of significance with n1 plus n2 minus 2, which is 13 degrees of freedom, so tabulated value is 2.16. So here t calculated, that is 0.96, and t tabulated 2.16. So t calculated is less than t tabulated, therefore we accept H0. Accepting H0 means there is no significant difference between sample means.